Question 5 is a fairly tasty question on binomial expansion, complicated by the fact that we have two variables within the brackets. So we're given the expansion and told that the constant term is 5,103, and we're asked to find the possible values of p. So to start off with, we should be able to recognize that we are going to be looking at choose r, so r is some number that we don't yet know, x cubed over 2 to the power of r, and then p over x to the power of 8 minus r, bearing in mind that these two exponents have to add up to 8 together. Now, there is going to be some value of r such that the exponents in x here and here, once you've taken into account these values of r, will cancel out and leave us x to the power 0. Now, you might just be able to, through trial and error, or just see what value of r would make the x terms counteract and disappear. However, there is a method to calculate it if you can't see it straight away. So to do that method, you don't have to do this, but I think it helps. So I'm just going to look at the x terms. So in the first instance here, we've got x cubed. So I would have x cubed to the power r, and I'm multiplying that by, here the x term, because it's on the denominator, it's actually x to the negative 1, and that's going to be all to the power of 8 minus r. And I know that because it's the constant term is x to the 0. That's the only way the x term can disappear if you have x to the 0, which is, of course, 1. So, again, using the laws of indices, we know that if we have a power raised to a power, we can multiply. So we've got x to the 3r multiplied by, this is going to give us x to the negative 8 plus r is going to equal x to the 0. And again, using the laws of indices here, if we are multiplying, so they both got the same base, we're multiplying these two powers, we're actually going to add them. So we're going to end up with 3r plus negative 8 plus r is going to equal 0, just comparing the powers. So just tidying up and simplifying, we can see that 4r is going to equal 8, so therefore r equals 2. So there's not actually any marks for this method, and you can just do it by trial and error, but I prefer having a logical method to it there. Anyway, once we've established that r equals 2, we can come back here, and we know that the constant term is 5,103. So now we've got a little bit more information. So we're looking at 8 choose 2, x cubed over 2 to the power 2, and p over x to the power 8 minus 2, which is 6. Now, because of Pascal's triangle, you might have ended up with 8 choose 6 here. However, the value will be the same. 8 choose 2 and 8 choose 6 are the same value. Anyway, we know that this term is equal to 5,103. So we can now continue to work this out. So we know that, or we can on our calculator find out that 8 choose 2 is going to give us 28, and then that's going to be multiplied by x cubed to the power 2, which is going to give us x to the 6 over 2 squared, which is going to give us 4, and that's going to be multiplied by p to the 6 over x to the 6, and lo and behold, you can see those will cancel out, and that is going to give us 5,103. So just tidying up, we end up with 7p to the 6 equals 5,103. Therefore, we can say that p to the 6 is going to equal 5,103 divided by 7, and then if we just take the 6th root of that, we end up with p is equal to plus or minus 3.